In beginning the structural T project, the first thing you want to do is we want to look at the parts that we need to make this piece, lay them out, and check them against what's on the print. Do not assume that just because these were pre-cut parts that they are correct. You should never assume that. So looking at the print, check all your dimensions and make sure they're correct. Make sure these are actually square because it could be miscut. Assuming that all the parts are correct to the print is something that can land you in some really hot water, because if the part was miscut by the person supposed to supply you with parts, now you're stuck with that error and you've missed it and incorporated it into your work. So check all your dimensions, make sure they're correct. You've got the right number of parts and the right size. You can see clearly right here, this one is not according to the print. It is the correct diameter of pipe, the correct thickness, but the length is wrong. So you would need to get another one. This is a very, very important thing. The next thing you want to do is remember that wherever your parts are going to be welded, you need to remove a 1/2 inch of the mill scale and the surface from all the parts. So even though these are clean metal, there's no mill scale on there, there's still skin on there, and there's still quite a bit of oil which needs to be removed. So this side, here, 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 any edge that is going to be touching the liquid metal needs to be cleaned thoroughly before use. Also, check for burrs. Little burrs sticking out from the cutting process may not allow the part to sit evenly when you tack it up. They may be leaning one to another or even fall over. So check for burrs, remove them if necessary. Make sure your parts are correct before you lay them out. On the pipe is going to have a very heavy layer of scale. Again, remove at least a 1/2 inch around the edge before you begin. Remove any burrs that are around the edge of the pipe because then it will not sit flat. So the next thing here is getting the last of the plates on of the small box. So as you can see here, I've got one clamp here and one clamp here. I want one on each side because if you clamp down this way, this end is going to open out. So you need to balance these two forces. Otherwise, when you clamp down here, this joint is going to spring open. Now, I've had it on the side here because since I know this is 3/8, it's already set, it's tacked in place, this is not moving anywhere. If I check it with my square, get all lined up, I know that's 3/8, 3/8. It's all dead square, and it is proper to the print. I also have easy access to be able to tack here, tack over here, and I can turn it over and tack the other side, but leaving the clamps in place. So the way it's done now, the clamps are not going to interfere with turning this over, so they're in a good placement. If I have them up here, then it would get in my way. So think ahead where you're placing your clamps, where you're putting your fixturing parts, so that when you move the part to access the other side, they're not in the way. So it's very important to think ahead, you know, like a game. Think moves ahead so that you don't end up getting in your own way. And again, I'm putting the tacks in locations that are not going to interfere with this. If you put a tack right up in here, how on earth are you going to get to it? There's no way to access this part with a grinder, and don't even think about using a burr, a carbide burr to get in there. That is just not going to happen. All right, you need to be able to do this without having those problems. Now, you can see there's a slight gap in here. These plates were shear cut, so there may be a little bit of a slight angle on the plates. I did grind this one up here a little bit in order to get flatter, but that's not a problem. That's going to be easily filled with weld. That's not an issue. But if the plate does stick up enough or has a slight bow in it or a burr from cutting, you need to grind that down so this can rest flush all the way across. So check all your parts. Don't assume that they're correct. Even if they are square, they may have a very substantial burr, or if you've got an angle, it may not be so you have a slight angle from cutting on a dull shear. So check all your parts before you tack them out. All right, here's the setup as I'm welding out the first two pieces. Please take a look at how many clamps I have on here. 1, 2, 3. Now the first one you saw, which is holding the angle block and this piece in alignment perpendicular. This clamp is keeping the angle block from rising up as I tack here. This clamp is pushing the block down so the tack on the other side doesn't pull the block up this way. This is important when you're tacking out your parts. Don't just hold them there and expect them to stay where you put them. They're going to want to move. There's equal and opposite reaction. Tack here is pulling up this way, okay? The tack here is also pulling that way, like that, so this back end is going to rise up. You need to think about that when you're tacking material in place. Where is it going to go? And then make sure you prevent that from happening. Wait till the tacks are completely cool before removing your clamps. If you remove your clamps too quickly, the metal is still trying to go somewhere and it's going to move on you. So don't rush. So the three pieces are together now. Now this part is clamped in place but not welded in place. Now I could put a tack here that would hold it very securely, but now I've got a big bump right where I need to put a part. So what I need to do is put tack here, okay, and here, small, and be really confident about it. Now you could put a tack here, but you'd have to make sure that you grind it down flush again. So it is possible, and that would prevent having anything in the corners, which could be an issue when you're welding in the inside corner. So I'm going to put the tack over here, but then I'm going to smooth it down so that my inside corners are free from any lumps when I go to tack. The same thing is true on the back side over here, where I'll put a small tack over there that will not interfere with what I need to weld. So I always want to think ahead here. So as an autogenous weld, and I'm using TIG just for clarity here. I mean, you could use stick or MIG, either one. This is very flat, so I probably won't have to grind that down, but if I did have any kind of lump, I'm going to grind that flush so that nothing will impede putting the next plate in place. Okay, the next step is laying out and securing the pipe sections. So the pipe sections are going to be secured on two faces, here and here, or to the other side, doesn't matter, but we're going to lay them out the same way. So what you want to do first is find your center lines, and okay, well I got a square surface and I have a round object. How do I center this up? Now the first thing I want to do is measure the diameter of the pipe. Okay, and I measured this and it's 2 7/8 to the outside, which means if I divide it in half, it's 1 7/16. So if I measure here 1 7/16 and mark that all the way around, when I place the pipe and make sure to just have that mark visible on all my sides, there it is over here. My pipe will be exactly centered on this surface. And I can double check it by just looking down inside and make sure that crosshair is dead on. Okay, so that's the method for laying out a round object on a flat surface. You have to measure your diameter, divide it in half, put it down, make your marks, and there you go. You lay it out diagonal, it doesn't matter. But following that is the easiest method and guarantees your pipe is dead on center. Now, a very important point here is that sometimes when you do this, if it's saw cut, your pipe may actually be a little crooked. So you want to be very careful about checking the pipe and making sure that it's actually perpendicular. If it's really way out, mark the high side, grind it down a little bit, put it down. And if you still have a little bit of a tilt in there, okay, what you can do is weld on the low side. It's going to pull it back like that, straightening it out for you. So make sure you do this. These need to be perpendicular to this surface. On the print, it says so, because when you mount your flanges, these need to be parallel to here. Otherwise, nothing is going to be square. So you need to check these very carefully. If they're really out, they need to be corrected, and you need to grind the surface to correct for that. It's very important, okay? I checked these ahead of time, and I cut them down to make sure they're dead square, so when I weld them on, they're good. Now, in welding these on, these lines on here are actually very useful as well, because what they're going to let you do is use those to guide you, okay? When you weld a pipe onto a flat surface, don't just weld anywhere, okay? We need 4 tacks. You're going to weld here and here first, opposite each other, okay? That is going to allow you to correct the pipe this way, this way. If you have to correct it, you can move it a little bit, tack it in place, and then tack the other side, and you'll have this fixed. If you tack it 120 degrees, there's no way to square a triangle. It's not going to work. You need to do 1, 2, check it, tilt it if you need to, 3, 4. Very important. And if it's not right, you can just break a couple of tacks in the, and to allow you to a hinge to move it where you need to move it. So please follow that, okay? Very important stuff. Also remember, you need to remove a 1/2 inch of scale from the pipe before you tack it down. You can't have any scale here. That's going to cause a lot of problems with your weld. Even if it's flux core, it's not going to allow you a very nice penetration of the toes into the surface here. It's going to be curled under slightly, or if it's very worse, you may even see some small pinholes. This scale and pipes can be quite thick. Sometimes we even have some paint added to it, so be aware of that. So taking a look at how these pipes are mounted, this one over here is pretty straightforward, okay? This is either a 5F or a 6F, depending on how you wish to position it. And the tack welds are pretty easy to deal with, pretty self-explanatory. Now, the top one here, this is dropped down 3/8 of an inch. So you actually have a lip here. There's going to be a 3/8 inch weld here, and you're gonna have the weld around the pipe. So this part is very tight. How you do this is going to be something you really have to think about. Now, trying to do this all in one shot, coming from this side and going this way, you're not going to get around this. You're going to run into this, is going to get in the way, and you can't access it from over here. One way to do it is start here, stop there, start over here, come this way, and do your tie-in crossing right in the middle. Same thing over here. Start here, come to the end, stop, come here, light up, go to the end, then start your bead and cross over right in the middle. That way you avoid going this entirely. Another option would be, let's say if you're stick welding, you could bend your rod to go around this way if you want to, or perhaps tilt this thing. So you have to really think about this edge very carefully. This is intentional. A lot of times things are not placed in an ideal fashion. That makes it very difficult to get to. Now, the next thing is how this is going to be mounted in position. You could grab it here and suspend it this way, or on this face, tack weld a small piece of metal on this side over here to serve as a tab to grab a hold of that you will put in the clamp. Or maybe down here, it's up to you. But you have to think about that. That's temporary and will be removed. So don't weld it to death, because that's not part of the print diagram. Only this is. Anything else you add on has to be removed at the end of your work. So if you're gonna tack one on, don't weld it to death. Tack it strong enough to stay in the air and stay where you need to put it, but removable. This is heavy, so your tacks better be good. So this is the completed structural tee element right here. As you can see, 1/2 inch of the scale has been removed on the pipe area right here. All right, now this was done with a file. You could use a grinding wheel, but I find that to be very coarse. You end up with, a lot of times, very coarse scalloping and digging in unless you're really careful. This is on a hand file. Just going, marking out a 1/2 inch and just going, and you'll feel that the scale is noticeably harder. The file will skate across the surface, and then all of a sudden when it reaches the metal, it will bite in, and you can feel it. You have your eyes closed, and you'll feel the difference in the way how hard the scale is, how soft the metal is. This should give you an idea why you don't want to weld through this. This is hard. It takes a lot of power to burn through this. And by the time you burn through this, the metal underneath is overheated, a liquid mess. So do yourself a favor, remove it. Now you can remove the edge here or just do the whole pipe. But this is the minimum, is a 1/2 inch on any surface that has mill scale. If these plates were hot rolled, you'd have to remove mill scale a 1/2 inch greater diameter around the base of the pipe. Since these are cold rolled, it eliminates the problem. As you see in here, if you had a scale problem inside of this thing, you would be in really bad shape. But since cold rolled, we're okay. But still, remember, remove all grease, oil, right before welding, wipe it down again. If it's been sitting till the next day, it could have dust on top of it, who knows what. Remove it before welding every single time. Wire brush, acetone, just to be on the safe side.